Brim you stable. Brim you stable.
Touchdown confirmed. We're safe on Mars.
There is the wheel of the rover.
Is that a shadow?
That's the shadow
of the rover.
Curiosity rover on the surface of Mars. I can't believe this. It's unbelievable.
Curiosity is the most complicated vehicle to ever be built and sent to Mars. And the primary goal of the mission is to search for habitable environments.
With Curiosity, we're trying to understand whether or not Mars had the capability of actually supporting life. So the three primary prerequisites for life are water, an energy source, and carbon. Now we know that Mars has had water on its surface. And we know that the sun is there providing all sorts of energy. But where's the carbon? The only way to find it is to get on the ground and bring the tools that we need to test for it and go look.
Well, we landed on August 5th of 2012, and then we had about 20 days where we did checkout, making sure all the instruments were working properly, making sure that Curiosity, all her subsystems were working properly. And now we're beginning to drive towards Mount Sharp. Well, Mount Sharp is a fascinating place. It's the reason we chose the landing site. What you see there is a mountain of layers that's about 5 kilometers high. And we think it's just the right place to search for organic carbon. So it's like reading a book. You start at the beginning, which are the layers lower down in Mount Sharp. And as we drive from the lower reaches to higher up Mount Sharp, we're basically going through the history book of early Mars.
Carbon is a requirement for all of life. Carbon provides a backbone element for creating the vast majority of molecules that we have in biological systems. And we call those molecules organic molecules. Carbon has the flexibility that life can use to do what it needs to do, to function. And we're looking for that source of material that life could potentially tap.
Right now we're in the Mars Yard, which is a facility that we have here at JPL that attempts to mimic what we might encounter on Mars. So when we're driving on Mars, we have to get to where the scientists want to go. Every day they basically say, hey, let's go to that rock over there. And it's our job as the rover drivers to safely navigate the rover from point A to point B. And there might be rocks in the way or steep slopes and loose sand, and we have to navigate all of these different challenges and keep the rover safe. We have found traverses where we can make it up most of the way of Mount Sharp, keeping at slopes below 30 degrees. And we can see from orbit how steep are the hillsides, but we don't know from orbit, is it really loose material? Is it hard packed material? And will the rover be able to really make it up those slopes? That's one of the things that we won't know until we get there.
The reason that we went to Mount Sharp is because we have satellite data that suggests that there were clay minerals present and sulfate minerals present. The reason why these two minerals are important is because they are well known for preserving organic carbon. The clays and the sulfates encapsulate organic materials and protect them. And if we want to get to those organic molecules, we have to crack them from the rock itself. We have to release them from the rock. This is a piece of gypsum, and we're interested in gypsum because Mount Sharp is actually composed mostly of this rock. And the Curiosity rover would first drill it, and then take some of the drill powder and give it to Sam. Sam is a box inside the belly of the Curiosity rover on Mars. And condensed inside that box is an entire laboratory for analyzing the chemistry of different rocks and sediments on Mars. We heat up a sample to really, really high temperatures, which will turn that sample into different gases. And the gases get sniffed by the mass spectrometer. That mass spectrometer takes all of the different gases there and it tells us the different molecules that are in that sample. If it's a large molecule, it will break it apart into small pieces and identify each of those small pieces. And with a whole bunch of if, ands, and buts answered, we might be able to address whether or not those rocks actually have organic carbon in them now, or if they ever did in the past.
We may or may not ever find evidence for organic carbon during the course of Curiosity's mission. And that's okay with me, because what we're still doing is learning about the environmental evolution of a planet that's very close to Earth. They both started out kind of having the same conditions, and then as time went by, Earth went in one direction and Mars went in the other. And so by looking at what we see on Mars, we get a better context to understand what led to the emergence of life on Earth.